Hey guys, so today we're going to be talking about one-step equations as part of equations and formula. This is the first video on equations. So what is an equation? Well, basically, an equation is any algebraic expression that has an equal sign. So we have a left-hand side and we have a right-hand side. What do we do with equations? Well, I like to think of equations as sort of like a game where we have to solve the equation by finding the value of the pronumeral. Or I like to say, getting the variable or the unknown, such as x, y, or whatever it is, by itself on one side of the equals. So we'll talk a little bit more about how we play the game later. But let's go with the basics first and let's talk about inverse operations. Now, inverse operations are what we use to get rid of whatever's with the pronumeral. And you'll understand what I'm saying when I go through a few examples. But let's go through what inverse operations are. So if you have a plus, the opposite or inverse of plus is minus. And if you have a minus, the opposite or inverse of that is plus. Same with times and divide, they're opposite each other. And square or square root, they're opposite each other as well. And you have nth to the nth root as well, and we'll go through that a bit later. What are the rules with equations? Well, rule number one is whatever you do on one side, you must do on the other side to balance the equation. You have to do the same thing on both sides. And rule number two is leave the answer to the equations in their exact form, for example, fractions or surds. We avoid rounding off answers in equations because sometimes we use that answer to sub in for something else later, and we want it to be as accurate as we possibly can. Now, all of this may sound a bit gibberish to you. Let's go do a few examples so that you understand what I'm talking about. Okay, so let's look at the examples that we have here. So example one, if you see it in maroon there, is x plus 2 equals 6. Now, on the left-hand side, I have x plus 2. The pronumeral is not by itself. I have a plus 2 with it on that side. My main aim of the game is to get x by itself on this side of the equals. So I need to get rid of plus 2. Now, if you remember, the opposite or inverse of plus is minus 2. And rule number one, whatever I do on one side, I must do on the other. So I do minus 2 on both sides. When I do minus 2 on both sides, well, that cancels that out. So I have x by itself here, and I have 6 minus 2. So x is by itself because the other 2 cancelled out, and 6 minus 2 is 4. The answer is x equals 4. Let's do example 2. Example 2, with the pronumeral, is a minus 2. The opposite of minus 2 is plus 2. So on both sides, I'm going to add 2 to cancel that out. Now I have x equals 6 plus 2, which is 8. Let's look at example 3. Now example 3 says 2x. Well, 2x is actually 2 times x. There's a times in between there algebraically. So what's the opposite of times? Well, the opposite of times is divide. So I can write that as a fraction, divided by 2 on one side, divided by 2 on the other side. Those 2 cancels out. Now I'm left with x equals 6 divided by 2, which is 3. Let's go on to example 4. This is x divided by 2. The fraction line means divided by. So what's the opposite of divide? Times. So I'm going to times 2 on both sides to get x by itself. Well, that cancels that out, and I'm left with x equals 6 times 2, which equals 12. Pretty simple so far. Let's go on to something a little bit harder. So example 5 is x squared equals 9. Now the opposite of squared is square root, or the inverse. So I'm going to square root both sides. When I square root this side, it cancels the square out and x is by itself. Remember, it's a game. Let's get x by itself. So x equals the square root of 9. What's the square root of 9? Well, that's 3. So the answer is x equals 3. Now let's do the opposite of that. We have a square root. What's the opposite of square root? Well, it's squared. So I square both sides. That cancels the square root out, and 2 squared is 4. So x equals 4. Let's go on to something a little bit more difficult with example 7. Example 7 says 3 times x equals 7. What's the opposite of 3 times? Well, the opposite is divide. So I divide both sides by 3. Now x is by itself here, but I have 7 over 3. And that's not a terminating decimal. That's a decimal that keeps going, or irrational decimal. So remember rule number 2, we leave the answer as a fraction if it cannot be a terminating decimal or an exact value. So x equals 7 over 3. Now remember our rules, use the opposite, and whatever you do on one side, you must do the same on the other side. Now, how do you know if your answers are correct? Well, let's have a look. We can check our answers by substituting back into the original question. For example, let's do example 1. We said that x equals 4. So if I put a 4 there where the x is, well, that'll be 4 plus 2. What's 4 plus 2? It does equal 6, so that's the correct answer. If I got, for example, x equals 2 there, well, 2 plus 2 equals 4. That's not the right answer. So we can always sub this back in to see if we got the right answer. Hopefully those examples helped you a little bit. I got a few quick questions here that I'd like you to do. Pause the video, go through the questions, and then come back and check the answers. Well, there you have it. They're the recommended answers. Hopefully you got them all right. If not, go back and watch the video again just to clarify where you went wrong. That's all for today, guys. Take care.